The loss of executive drive and discipline is not a psychological flaw, but a structural hardware failure in the brain. Repetitive exposure to friction-free digital environments creates a neuro-hijack, overloading the mesolimbic reward system. This decline is a predictable molecular response to modern digital friction, requiring a forensic audit of the resulting neural damage. The brain treats chronic digital hyperstimulation as a physiological threat. To defend against the persistent flood of dopamine, it physically retracts its own receptors. Clinical data shows that chronic digital friction leads to a minimum 20% drop in dopamine D2 and D3 receptor binding potential. This retraction raises the threshold for experiencing a reward. It makes slow-paced, strategic business wins feel completely unrewarding compared to rapid digital microstimuli. Without baseline dopamine sensitivity, executives lack the biological capacity to maintain high-effort, long-term initiatives. This pathology is driven by delta phos-B, a highly stable protein that accumulates inside neurons with every digital micro-interaction. Delta phos-B functions as a molecular trap with an 8-day half-life. The associated reward debt remains long after the executive disconnects from digital platforms. This protein buildup physically severs the neural connections between the brain's motivation center and its executive planning center. Network analysis highlights the severity, showing a 24% reduction in connectivity to the prefrontal cortex and 27% to the parietal cortex. This systemic disconnectivity isolates ambition from strategic execution, severely impairing the neural capacity for goal-directed behavior. Dopaminergic hardware can be resensitized through a strict 3-pillar biological protocol. Pillar 1 requires a mandatory 30-day digital fast. Complete abstinence is necessary to allow stable delta phos-B complexes to naturally decay. Pillar 2 utilizes high-intensity interval training. Pushing the body to maximal oxygen uptake forces the brain to upregulate dopamine synthesis, increasing D2 receptor binding in the nucleus accumbens shell by 16%. Pillar 3 involves retinal light control. Blocking late-night blue light stops the brain from activating anti-reward signals that suppress baseline dopamine. By auditing digital friction and applying this protocol, high performers can return their hardware to a functional state and reclaim their competitive edge.